Okay, so a little bit about what the Triple O Quick Start project, what problem it's trying to solve first, and then I'll start a live demo that will run a full end-to-end deploy with a heat stack validation similar to what Triple OCI uses for validation. And while that's running, because it's pretty boring, it'll take about a half hour to run all the way through. But while that's running, I have a Askinema recording of kind of more step-by-step that we can go through and explain what the Quick Start playbooks are doing at each particular step. So the reason that I started this project was spending a lot of time in RDO helping new users trying to try out Triple O for the first time. And the feedback that I kept getting was, it takes too long. It's complex. There's a lot of places where you can just make a small typo while following the docs and get into a rabbit hole trying to dig yourself back out of that. The tool in Triple O currently that does this is Instack Vert Setup, which is written in Bash. It mostly leverages the dev test scripts from Triple O Incubator. So you've got a Bash tool that's calling into a bunch of Bash scripts in a totally different repo, which I found trying to explain to new users and trying to help people navigate that is really hard. And then beyond that, like, to contribute to those is also pretty hard. I have a pretty good understanding of how all of those fit together, and I still kind of struggled to think of how to integrate the main feature of Triple O Quick Start, which, in case you don't know, it deploys from a pre-built undercloud.qcow2 that has all of the installed packages needed to install the undercloud, as well as pre-built overcloud images, both the overcloud full image and the Ironic Python agent RAM disk. So it drastically speeds up the time, and because you're providing pre-built images, there's also a lot less room for error. The Undercloud QCOW2 idea came from the OPNFV Apex project. It's helping them with their last release, and they were using a similar idea, and we kind of worked together to create the undercloud.qcow2, and we actually shared it for their Brahmaputra release, used the Liberty undercloud.qcow2 created in RDO. So that was kind of cool. So without further ado, I'm going to go ahead and kick off the live part of the demo. So let's see how screen sharing works here. All right, so hopefully folks read that okay. But so I already have the quickstart.sh downloaded. Really, all we have to do is run it. I'm passing it a pre-made config file. We'll get into that config file in the step-by-step demo. And then I'm giving it a host name that I can SSH to as root without password. that -t all is not the default. That's it passes tags to Ansible playbook command. That's what it's running under the covers. And by passing -t all, we're actually going to run all the way through validation. By default, it will stop at a different point, and we'll get into that in the scripted portion. But I'm just going to go ahead and kick this off, and we're off. So in about 30 minutes, that will be done, and we will have a deployed and validated overcloud. So I'm going to stop sharing that screen and go to the scripted portion. Portion is saved on Askinema. It's a command line tool that just captures all the standard in and standard out. So folks could look at this after the demo very easily as well. Just going to check IRC real quick before kicking this off. So there's a question on IRC about not using localhost. It actually can run fine if you run it directly from your hypervisor and run it against localhost. I'm actually running it Ansible from my laptop, targeting it's sitting on my desk. So it can run in either way. All right, so let's go to the scripted portion so we can walk through what's actually happening here. All right, there we go. So we just do a couple things early just for convenience. Save the vert host off. Here, I'll pause this. It's getting ahead of me. All right, so we save the vert host just to use it later in this demo. And then we're going to build up a configuration. Everything is defaulted, and that is a kind of design decision of TripleO Quick Start, that if you run with no extra configuration, you should get something that works. But at the same time, almost everything is configurable, and it's also a goal to make things really flexible so that it can be used for a lot of different contexts. So to start with here, we're just building up a config YAML and we're going to define 3 overcloud nodes three overcloud control nodes so that we can do an HA deploy. The flavor here, it actually will create a flavor for us that matches the hardware specs we're giving those VMs, and also tags it. And then in the instackinv.json that we create, the nodes are also tagged. So we can do stuff like give control nodes more memory or compute nodes more memory and know that we're going to get control nodes deployed to the right profiles. All right, so let's continue that. We got our 3 control nodes and a compute node. And then, well, the only other thing we're going to pass in for this demo is just the extra args to pass to the overcloud deploy to enable HA. So TripleO Quick Start will take care of all the flavor stuff for you by default. We just need to tell it to deploy 3 nodes and use the pacemaker environment to get pacemaker HA. And we give an NTP server just because HA likes to have things synced up. All right, and that's our config file. All right, and so now we're gonna just run the quickstart.sh script. That's just a really thin wrapper around Ansible playbook. We're gonna run that with just the defaults. And so that's just gonna boot up our undercloud.qcow2. By default, we can change this behavior by switching what tags we use, but by default, it will actually create all of the scripts on the undercloud that are needed to deploy whatever we've configured and passed in via config. But it won't actually run anything. Like it will boot up the undercloud.qcow2 and it won't actually run anything. So this would be like the breakpoint for someone just trying this out. Also for a development use case where you're just wanting to get an undercloud up quickly and then do whatever you need to work on development wise and then continue by hand or either with more tags as we'll show later. So it's just that simple. This bash and quickstart.sh, pass it our config file and our vert host. Now this will take a little bit. We'll skip ahead. So we're getting the undercloud from cache here because we have built-in caching. So I've been using the same undercloud.qcow2 for a while, so it's in my cache, which makes it to where I don't have to download it over and over again. And drastically speeds up the deploy. We inject some SSH keys. Skip ahead here, installing it into the libvirt volume pool. And we booted it up, it's got an IP, we're just waiting for SSH come up. And here's where we're just creating all the scripts that could be run manually or could be run by tags later on. And then if you run with the defaults, the default tags, it will print out this message at the end. This is actually one of the main reasons why I made a wrapper around Ansible Playbook. Ansible is not really great about giving instructions at the end. So this just gives kind of a new user some things they could do with this undercloud that they've booted up. But as you can see, if you did it manually and then wanted to just follow the docs and ignore the scripts, it hasn't even run undercloud install. So no Puppet has run, no Keystone initialization, just packages, repos, and overcloud images, and a stack user. So we'll continue on with the demo here. It creates a SSH config for you so that you can access the undercloud directly without SSHing to the vert host and then jumping from there to the undercloud. It just creates that for you. So here we SSH to the undercloud. There's no stackRC yet because undercloud hasn't been run. And like I was saying, it's just repos, installed packages, overcloud image and RAM disk, and then a non-root user with passwordless sudo permissions. And so we could just run those scripts one by one to build up our deploy, but we're going to do it with tags and Ansible because all of the under and over cloud tasks are tagged. So here we'll start with the under cloud install tag, and that tag just runs really one task, the OpenStack under cloud install. And so now we're installing the undercloud. Because we have all the packages pre-installed, installing the undercloud is actually only 2 or 3 minutes, but we'll skip ahead here. All right, so we've installed our undercloud. More like 7 minutes, not 2 or 3, but still pretty fast to get up a fully configured undercloud with all the services running at this point. We're only about 13 minutes in. All right, so then from here, let's SSH into the undercloud again and see what it looks like after this step. All right, so now we have a stack RC because we've actually configured the undercloud with our undercloud credentials. So we can source that and then start looking at what's actually in there. Nothing, because we've just run the undercloud install. So we have all of our services, but there's nothing, it's not ready to deploy yet. We have to do more stuff to be able to actually deploy our overcloud. All right, so then now we'll go to the next task. There's a tag for undercloud post install, and this will do all the steps you need to prepare for deployment. We'll load images into Glance, we'll register our fake bare metal nodes to Ironic, and we have the ability to optionally introspect fake bare metal nodes. It's not really a useful thing for a virtual install, but for the CI use case and for developer use case, if we're testing something to do with introspection, then we would want to do that. And then it creates the tagged flavors for us too. And this task doesn't actually take that long. Because I didn't configure introspection to run here. So there we go. So that task, 28 seconds. All right, so now we actually have a undercloud that is ready to deploy. Let's log back in, take a look. So we got nodes in Ironic. They're all powered off and available. We got images in Glance. We got our deploy RAM disk and our overcloud full image. No deployed overcloud nodes yet because we haven't actually run a deploy. And still no heat stacks because we haven't run a deploy. So the obvious next step is to run the deploy. There's a tag for that. It's overcloud deploy. this is the longest part of doing a deploy. HA takes longer than non-HA as well. I think this probably takes close to 15 or 20 minutes. Let's skip. Okay, there we go. So it took 20 minutes to deploy the overcloud. So now we can log in and check that out. You'll notice I made this demo this morning too. So I mean, it's not live. We'll switch to the live one just to prove to you that this does actually work. But it is from this morning at 6:30 in the morning, so pretty close to live. Although I may have dozed off here when screen capping this. There we go. Yeah, so we've logged on to the undercloud again. Now we've got our nodes, but they have instances attached. Sorry for the screen wrap. It's just the way it is with UUIDs being returned. And in Nova, now we've got our instances, got our 3 controllers and a compute. And most importantly, our heat stack is create complete, which is always nice to see. And we should, at this point, unless something has gone wrong, have an overcloud RC, which is our credential file to access the overcloud. And if we source that and then do a Nova list, there's no overcloud images or nodes yet, because we haven't done anything there, but we can auth through Keystone and get a response back from Nova, so things are looking good. All right. Going to combine the last 2 tags into one, mostly because the post-deploy configuration doesn't do a lot, but we want to separate validation from post-deploy so that you can have non-idempotent tasks in post-deploy, but you could run validation over and over and over again. And we're using the ping test from triplo.sh for validation. Running Tempest on a HA setup on a tiny vert host is not likely to produce good results. It is possible to run Tempest against a single compute, single control setup on a vert host. I've had success with that. But the ping test is just a simple heat stack that boots up a VM in Nova, and then we try to ping it. It plugs it into the network, and then we try to ping it. This example also shows how you would pass multiple tags. So for this demo, we've just been building up an undercloud kind of 1 tag at a time. But you could use something similar to how we've used multiple tags here to just pass all the tags needed to get to the exact point you would want to do something manual before continuing on with the rest. So say I'm working on some feature that requires Triplo heat templates changes. I would want to run all the way up until the overcloud is run, make my template changes, and then run the rest of it to see how my template changes worked. So the ping test is pretty fast. We'll go ahead and let that run and check the Ansible output. Skip a little bit here. It takes a couple minutes. And there we go, success. About 3 minutes for the ping test. And that's it for the scripted part of the demo. Check back in on our unscripted part. All right, so the unscripted part is still deploying the overcloud. It's been going for about 20 minutes, so we should be actually pretty close. But I can take questions at this point. Probably the only way that I know how to see questions is if you asked on pound RDO on Freenode. Otherwise, we'll wait for this live part of the demo to complete. And good question. So the question is, where can I check the output of the tasks that Ansible is running? The files they log to are configurable, but it will log to the home stack directory. Let's see. In this live demo, I can show this. So I'll just split this. So on the undercloud, this is the live demo that's running right now. We could actually just tail the overcloud deploy log. So by default, oops, to make this consistent. By default, the overcloud deploy command will log to this overcloud deploy log in the stack user's home directory, but it is configurable what file it logs to. We'll have to wait a little bit for something to happen there. Similarly, there's a undercloud install log that will have all of the output from the OpenStack or undercloud install command. Same with the validation. It all gets logged to the stack directory by default. Another great question. Okay, so the question is, if I would like to test a specific patch for the undercloud or the overcloud, how can I get that into the deployment that TripleO Quick Start does? So there's a lot of ways to do that. It's not fully defined, I guess, what the best way is right now. TripleO Quick Start only gates against itself. So it's not gating changes to other projects in TripleO. But Ben Nemec has a Jenkins server that builds RPMs for every TripleO change under test, and I often will use those RPMs. I'll link to that in IRC in a second here, because it's super useful. You can just find the change ID dash patch set of the change you want an RPM for, and there's just an RPM there, and you can boot up the undercloud. So if it's like a TripleO heat templates patch, you wouldn't even need to put it in the images. You could just boot up the undercloud, install that patched RPM, and test it out. So then there's another question in IRC. Let me know if I need to follow up with that previous question with any more detail. But the next question is, what about customizing things like network settings and instack env files? Can that be passed in, or is that a run some tags, make mods, run more tags? So network settings and the instack env files are totally handled. Lars Kellogg-Stedman has actually been making a ton of improvements to the way the networking is set up and simplifying it. I didn't show any of that in the config. There is an open issue on TripleO Quick Start to better document all the configuration options. So that's a little bit of a work in progress, but it is totally configurable. How many networks, what IPs are on them, what the DHCP range is for the external network. And the instack env file that JSON file is created from the nodes that you define. So if I define 3 control nodes and a compute node, then my instack env.json will have 3 control nodes and a compute node. And there's some other stuff that's configurable in there, but yeah, it's that part's not super well documented just yet. All right, we had a little bit of action on the deploy here. Any other questions while we're waiting for this deploy to finish? Hey, there we go. So we just deployed an overcloud. So now it's running that same ping test that we ran in the scripted version, just without any interaction from us this time. Go ahead and close down this connection. Wait for that ping test to come back and see what the output looks like when you're running with non-default tags. Since we don't really need that new user further instructions output if we're not running the total bare default. All right, there we go. So we completed, as you can see, it doesn't print it only prints out the Ansible task output, which kind of gives us an overview of which tasks took the most time. We can see that the total time from 0 to fully validated deployed over cloud was 32 minutes, and that's HA. So for a reference point, the OOCI gate jobs tend to take over 2 hours. So it's a pretty huge time savings and allows for really fast iteration. I can completely tear down my Mitaka environment and have a Liberty environment up on the same host within 20 minutes to get it to a point to start testing a change. So it's really nice for developers with limited hardware. I just have the one box on my desk, so being able to switch between releases really fast, not having to wait 2 hours to get a new environment up is really nice. And that's pretty much it. So if there's not any other questions, go ahead and end it there. Thanks for watching.